We are now in lesson number 17, that is page 126 of your textbook, and we will look at simple electrical circuits. So we will look at electrical components and their symbols before we go to electrical circuits, because the electrical circuit is made out of electrical components and they are represented in symbols. Okay. So each electrical component in a circuit diagram is represented by a unique symbol. The symbols are used internationally to indicate how components are connected in the circuit diagram. You will need to know what each component symbol looks like in order to draw a diagram. So in the diagram, we will use symbols. So now let's start with each component. The first component is a cell with a C, okay? Using English, so the cell with a C. So this is normally what we call a battery. So from now, don't call it a battery, it is a cell. And the symbol, okay, it is a short stick and a long stick. They are connected by lines, and the short stick is a negative connection and the long stick is the positive connection, and it is the input device. You must know it is the input device. And if we have two or more cells connected, we can now call them a battery. Okay, so this is a battery. If you see two or more, it is a battery. And these ones are connected in series because they follow each other, but you will see that when we get to connections. So you see the short stick and the long stick for the first cell, and then the short stick and the long stick for the second cell. Then we put the connecting lines, and you know the short one is negative, the long one is positive. The batteries are also input devices. We have battery again, but now the only difference is that it is connected in series, in parallel. This one was connected in series, this one is connected in parallel. So you can see we have the top cell, we have the bottom cell, and then we join the negatives together, the positive together, then we join the connecting lines on the side. The battery, we know it is the input device. And we have the push switch. You know the switch. This is the switch, and this is the symbol for the switch. And the switch, it is the control device because we control the circuit with the switch if it's on or off. It is a control device. You need to know the uses, okay? And when it comes to a switch, we've got a different type of switch. This one is a push switch, the one we started with. And then the next one that you see, it's a single pole, single throw switch. Single pole, single throw switch. And the short abbreviation for that is SP for single pole and ST for single throw switch. Okay, it is also a control device. It's drawn a little bit different. Okay, it's not like a push button. The push button will have the top a symbol there to show that you are pushing, but the single pole, single throw will look like this. And then we have the globe, okay, and you know the globe now, we sometimes call it a bulb, okay, globe or bulb. This is the symbol for globe or bulb. It is the output device. And we have the resistor. Here is the resistor. This is the symbol for the resistor. This is the process device. Okay, we have a bell and buzzer. Okay, this is how it looks. This is the symbol for bell and buzzer. They are combined, bell and buzzer. They are output device. They vibrate to produce sound if current flows through it. Okay. And then we have the light emitting diode, which is the LED. You remember on the terminology. Okay, this is how it looks like, the LED. You will see the real one because here in the book it's not clear. This is the symbol for the LED. It is the control device. Okay, so far we have how many control device? It's the LED and it's the switch. Okay, the two switches. Then we have a voltmeter. This is the symbol. It is the output device. Okay, we use it to measure the potential difference. And we have the ammeter, and this is the symbol. It is the output device. So the only process device that we have learned about so far, it is the resistor. Okay, and the process, it is the process, it is the resistor. The control, it is the LED and the switches, and the input are the cell batteries in different connections, and the bulb, the buzzer, and the voltmeter and ammeter are the output device. Very important to this table. Please go back and read it and understand the symbols before we're gonna go to electrical circuits. Now, since we know the electrical components, their symbol and their use, we can now go to electrical circuits and circuit diagrams in page 127. Okay, study the following electrical circuits diagram with symbols. You must understand the difference between simple series and parallel circuits. So we have a switch, we have the cell, okay, because it's only one. We have the cell, and we have the two globes and the bulbs. They follow each other in one line, so they are in series. Now, how do we draw the circuit diagram? We put the cell, remember, your cell, how we draw it, the short stick and the long stick, negative, positive. Then we connect the switch. This is the SPST, single pole, single throw. Okay, and if it's like this, it is open. If this line was closed, we were going to know it is a closed switch. Okay, then we have the globe, we have another globe. This is a series connection. We look at the parallel connection. We have the cell. What is connected in series in the circuit? It is the bulbs. Okay, they are connected in series. So now let's look at the parallel connection. The cell, we have the switch that is open. We have the two bulbs. You see they are in different lines. Okay, the other under the other. Okay, so this is on top, this is at the bottom. They are not in one line. Okay, so this is a parallel connection. So the cell is the same, the switch is the same, but look at the parallel connection. How do we draw them? You see the difference between the parallel connection and the series connection. Okay, this is the connection for the bulbs. Remember the batteries, we can also connect them in series. We can have another battery here, or we can connect them in parallel, having another battery, having another cell at the bottom. The cells, we can connect them in series. They will follow each other in one line, or we can connect them in parallel, where we will have another cell at the bottom, and in that case that will be a battery. It will no longer be cells. Okay, now let's look at the nodes. We are going to look at the series circuits. When the positive terminal, you see the positive terminal of a component is connected to a negative terminal. So this is the positive terminal. When you go all the way like this, we connect it to a negative terminal. When a positive terminal of a component is connected to a negative terminal of the next component in an electrical circuit, it is called a series circuit. The current in a series circuit is the same through each components. Okay, so you see we've got two components. Okay, so the current will be the same here and the current will be the same here in series connection. Okay, where are we? And the voltage is divided between the components. Okay, so the voltage will be shared by the components, but the current is the same in the series connection. This is very important. People at the higher level, even metric, they cannot or they are struggling to understand electricity because of these basics. So you need to know that current in the series connection is the same in all the components, but the voltage is shared by the components. Okay. And adding more lamps, which means adding more light bulbs to the circuit, will increase the resistance, and the lamps will not shine as brightly. So if you put more lamps, you increase resistance. Okay, very important. You increase components, you increase resistance, and the lamps will not shine as brightly. If one lamp fails, the current will not be able to flow and the remaining lamp will not shine. Okay, please let's get this clear. In a series connection, we are still talking about the series connection. If one lamp fails, the other one will not shine because the current will not flow. You see this, the line, the current flow in the line. So if this bulb fails, it's gonna be off and it will cut the flow of current. Then this next bulb won't be able to shine. Okay, two important things in this paragraph is that if you increase the light bulbs, you increase the resistance. If one light bulb fails, the other one will not shine in a series connection. Now, in the next page, page 128, let us look at the parallel circuits. When all the positive terminals of components are connected to one another and all negative terminals are connected to one another in an electrical circuit, it creates a multiple paths for the current to flow through, and it's called the parallel circuit. The voltage in the parallel circuit is the same over each component. You see, this is different. On the series circuit is the current that is the same. Okay, but on the voltage, on the parallel circuit, voltage is the same and the current is shared by components. This is very key. Please understand this. Lamps connected in parallel shine equally brightly, so the brightness will be the same. If one lamp fails, the remaining lamps will continue to shine because the current is still able to flow along another path. Let's see the connection. So we have a cell, we have a switch, we have two bulbs connected, and this is our diagram. Now, if this bulb fails, now let's see, current is coming this way, current is flowing all the way coming here. And if this bulb fails, current will come here but won't continue here. So this bulb will be off. But now here, current will continue and this bulb will shine. Okay. So if one bulb fails, the other one shines in parallel connection or in parallel circuits. So you see the difference between parallel circuits and series circuits. Now let's look at combined circuits. The same principles still apply to components connected in series and in parallel in a combined circuit. So let's look at this combined circuit. We've got two cells connected in series. They form a battery, and we have a switch. Then we have two bulbs connected in parallel, and we have another resistor that is in series. Okay, so this is a series parallel combination. So let's see our battery now. We have two cells, one, two. One, and we have another one. Then we have a switch. Then we have two bulbs connected in a parallel, and we have a resistor. Remember the symbol for resistor, and we have current going back. This is a combined circuit. Okay. And now in page 130, we look at electromagnets. Electromagnets consist of insulated wire wound into a coil around a metal. And the more coils wound around the core, the stronger the magnet. Let's read again. Electromagnets consist of insulated wire wound into a coil around a metal core. The more coils wound around the core, the stronger the magnet. Okay. So we see the example of the electromagnet in page 131. An electromagnet has a magnetic field. You remember when we were doing magnetism, we learned about the magnetic field that flows from the north to the south of a magnet. An electromagnet has a magnetic field as long as there is an electric current flowing through it. If the current is interrupted or switched off, the magnetic field disappears. So very important, you need to know this about electromagnet.